Hello guys, today we will learn about queue and its implementation using linked list. Okay, so what is queue? Queue is basically a linear data structure which follows a particular order of operations. Okay, so in queue, it's a linear data structure, and what operation it follows is it follows first in first out. Okay, first in first out means whichever data item is inserted in a queue first is popped out first, and it can also be said as last in last out. Like whichever data item is inserted at last will be popped out last. We have seen many real life example of queue, like people standing in a line for any specific purpose, like they're waiting for any sim card or any, like in voting is there, if voting polls are happening, then also people stand in a queue for their turn to come so that they can vote their candidate. Okay, so these are some real life examples which you can see. Now queue is very useful data structure. Okay, in computer science programming, there are a lot of places, like in operating systems, in network systems, it is used very popularly. Like in operating system, like semaphores are there, first come first serve scheduling happens of. So when CPU core scheduling happens, it is also done using queue, and in printers also spooling is done using queue. Buffers are there in keyboard, and there are a lot of producer consumer problems are there where queues are plays an important role. Many CPU scheduling, disk scheduling algorithms, everyone all uses this queue, all is uses queue. Okay, so in IO buffers also, IO buffers, pipeline, file IO, all these also, here also we use queue. And in networks, like there are queues in routers and switches, there are mailing queues are also there. So in those places also we use queue. So queue is a very useful data structure in writing programs, efficient programs, but there are a lot of things happening. So queue helps us to solve those problems very efficiently. The other variations of queues also, like D queue, priority queue, doubly ended queue, doubly ended priority queue. All these are some variations of queue. Okay. DQ, doubly ended queue means in both, from both places, from the front and or rear also, we can take out elements. Okay. And in priority queue, elements are given some priority, which if some new element comes which has higher priority, then it moves forward in the queue. And doubly ended priority queue is a mixture of DQ and priority queue. Okay. So now let's see what are the various operations that we can do in queue. In queue, there are four basic operations, like NQ, DQ, front and rear. Okay, we can also have one more operation, like size. This will represent. This will give the uh, uh, gets the size of queue. This also have time complexity big of 1. Okay. Okay, let's check out first NQ. NQ is nothing but adding elements in a queue. Whenever we want to add some element in a queue, it is called NQ. Okay, and elements are added at the last position. Okay, now elements are added in the last position. This you must keep in mind. Elements are added in the last position. And DQ is nothing but removing of elements in the elements from the queue. In this operation, elements which are at the front of queue are popped out. Okay. Now front and rear. Front is nothing but it's just, we are not popping out any element over here. It just get it we get a peak of what is at the front of the queue. And rear, we in rear rear function gives a peek of what is at the last of the queue. So using these two, we just get a peek means what is there. We don't pop the value out. Okay, pop or put, we don't do anything. We just check out what the value is, and size also we check out what the size of the queue. Okay, so NQ we put an element in the queue, DQ we remove an element from the queue, and front, rear, and side we just check out. Okay, what is at the front, what is at the bottom, what is at the last, and what is the size of the queue. And NQ is done at the last position, and DQ is done from the front position. All these operations cost big O of one time, that is constant time. Okay, as we are not running any loop for these operations. Now let's check out in Python what are the various ways we can implement queue. Queue can be implemented using list, linked list, collection DQ, QQ. Okay, so in this lecture we will be implementing queue using linked list. So this is how the code looks like. This is the node class. This is how we are defining the node class. Then this is class queue. Here we are defining three variables: head, tail, and length. Head points to the front of the queue, and tail points to the rear of the queue. Okay. Now in NQ we will try to insert an element. NQ will take in parameter data. So we will create a new node. We will initialize a new node with data value, and we will check if the length is 0 or not. If the length is 0, then it is the first element which is being inserted. So head and tail both will point to the new node. And if it is not, if the length is not 0, then what we will do, we will move tail one step forward. Okay, tail dot next equal to, sorry, it will be new node dot next. Wait a minute, self dot, no, it is fine. Tail dot next new node. Okay, self dot tail dot next, this will be new node, and self dot tail equals to new node. So this is how a new node has been inserted. So it will tail is inserted at the last of the queue. Okay, and we increment the length by 1. The element is inserted at the tail position, and tail points to the new element, and we increment the length by 1. Now let's check out DQ. What we do in DQ? If the size is equal to 0, then we will return none. Now we will make a separate variable item, and item is equal to self dot head, and self dot head is equal to head dot next. So we will move head one step next, and then we will check if the length, we will decrement length by 1. Now we'll check if length becomes 0 or not. If length becomes 0, then it was the only node in the queue. It was the last node. So we'll make tail as none. Okay, and then we'll make item next equal to none. So after this step, by garbage collection, item will be deleted from the memory, and we'll return the item dot data. Okay, whatever item dot data has, we'll return it. Now let's check how front function is defined. Front function, we check whether length is 0 or not. If length is 0, then we'll return none. Otherwise, we'll return head dot data. Okay, and rear similarly, if length is 0, then we'll return none. Otherwise, we'll return tail dot data. Okay, and size simply returns self dot length. Okay, that's it. It's very simple code. So you must understand DQ and NQ. Okay, how we are inserting the element. There are two cases. When there are no nodes in the queue, then this is followed, and when there is in DQ, when there is only one node in the queue, then this case is followed. Okay, you must check out the special cases. Okay, rest is very simple, and this operation is what we are gonna do. And it will, the linked list, the queue will look like 20, then hello, then Dominic, and head will point to 20, and tail will point to Dominic. Okay, so if we do front, so head will be returned, 20 will be returned. If we check Q, then Dominic will be returned. If we check size, then size will be 3. Then we do DQ data. So DQ 20 will be returned. After 20, returning 20, it will become this head, hello. Head will point to hello. Then again, if we check size, then size becomes 2. And now if we check front will point to hello. And if we check rear, then rear will point to Dominic. Okay, still it is pointing to Dominic. So let's run this code in PyCharm. This is the same code. You can see whatever I have defined there, the same thing I am doing over here also, defining over here also. This is the same thing. I have defined the node class, then 3 variables, head, tail, length, then NQ the special case with no node in the queue, then DQ, the special case with only one node in the queue, then front, then rear, then size. Okay, and these are the operations which I am doing. Now let's run it. See, first when we defined the queue, this is when we have defined the queue. Let's check out what is the front. Let's print these statements also over here just after defining. What happens? See, front is none, rear is none, and size is 0 right after defining. Then after that we are inserting 20, hello and Dominic. So now it becomes, after doing this, it becomes 20, hello and Dominic. Yeah, this is how it looks like. Now we are printing front will print 20, since head will point to 20, rear will print Dominic, and size will print 3. Okay, now we are dequeuing data. Once we DQ data is 20, whichever was in the front, it got DQ'd. Then again we are printing size is, after DQing this, the linked list becomes, the queue becomes this way, the linked list or the queue, what we can call it, both. Dominic, this is how it looks like now, hello and Dominic. Now if we print size will become 2, and front and rear will be hello and Dominic. That's it, guys. It's very simple. Hope you understand. So let's revise one more time. So queue is a linear data structure, first with operation first in first out. Whichever comes in first leaves out first. It has very useful implementation in operating system, in networks, in CPU scheduling, disk scheduling, IO buffers, file IO. It has lot of implementations. Okay, some other variations are DQ, priority DQ, double-ended priority DQ. These are some other variations, and these are the 4 basic operations. Maybe fifth one also, size. So 4 basic operations are NQ, DQ, front and rear. NQ is inserting element, DQ is removing element, front just checks out the front element, rear checks out the last element, and size gives the size. NQ puts the element at the last, DQ removes the element from the first. All are big of 1 time complexity. Okay, constant time. And we are implementing using linked list. This is the code one more time. These are the operations. Thank you, guys. Have a good day.